Okay, so we're going to pick up where we left off yesterday. We spent most of our time just talking about vertex form and how to graph from that. Now we're going to talk about if you're given something in like the more general form. So this, I mentioned this yesterday, but that's that ax squared plus bx plus c form. In this case, when you're trying to graph it, it's not as easy as, I think vertex form isn't super hard to graph because it's really easy to pull the vertex and it's easy to see the axis symmetry and all of that because you can just grab it from the equation. Can't do that with the general form. You have to do a little bit more work in order to find all of those things. The only thing that's probably really easy to find in general form would be your y-intercept. Everything else, so you have to do a little bit of work to find it. If you didn't grab a calculator when you walked in, I would go do that because I'm also going to show you again like how to use your table function to help you find your vertex really quickly. So either grab yours or go grab one of mine quickly. Okay. This is also something we did do last year in Algebra 2 when we spent all that time talking about quadratics. We were in quadratics for a lot of first semester last year. And so when we talked about graphing quadratics, we had to do these things. We had to find the vertex. We had to find the axis of symmetry and the y-intercept and all of that. To find your vertex, you're going to use this little formula right here. I always refer to that as it's opposite of b over 2a. And I say opposite of b because if the number is already negative, it is going to switch its sign to a positive. So I always refer to it as opposite instead of saying negative. And then it's all over 2 times your a. Now, the b and the a, those come from that equation. Those are the numbers that are in front of the x squared and the x. And then c would also be a number, but it won't have an x or any letter attached to it. It'll just be a standalone number. So we'll use that equation to help us find our vertex. Now you can do 2 ways to find the y coordinate of your vertex because that opposite of b over 2a gives you the x value of the vertex. To find the y value, you either need to plug the x value back into the original equation and like calculate that, or this is when we can do our shortcut with our table. We can type in our function on our table and actually figure out what the y value would be. So we'll get into that as well. Okay, so down below, we also have things, still deciding, does a parabola open up or down? That's looking at your a value. Is that going to then be a minimum or a maximum for your vertex point? That's all based on if it opens up or down. We'll find our vertex, we'll find our axis symmetry, and then we'll go on and continue to find intercepts, both x and y. For your y-intercept, it's just the c value. Whatever the number is at the end of the equation, that's your y-intercept. That's probably the easiest one to find. The x-intercepts, you're going to have to either try to factor the equation that you have or use another method. Most of the time, if I can't factor it, I'm not even going to try completing the square. I'm just going to go straight to quadratic formula. I don't want to waste my time trying to do something that's going to be a headache. And I know quadratic formula works all the time. So if I can't factor it, because factoring is faster, then I'm just going to go straight to quadratic formula and use that instead. All right, so let's do one together. So we've got this equation, negative x squared plus 4x plus 1. Is this one going to open up or open down? What's your a value? What number is in front of the x squared? It's a negative 1. So since it's negative, that means it's going to open down. Okay, so we know this is going to be like a sad parabola, which means I know my graph is going to look like this. And so this point at the top, that's going to be my vertex. That's going to be the highest point that I find on my graph. So my vertex is going to be a maximum because that's the tallest. Like you're standing on top of the hill and then it's downhill on either side of that vertex. I need to figure out what it is though. So I need to find the vertex and then I'm going to go ahead and circle that I know it's going to be a max just because I know what this graph should look like. But I need to actually figure out what the vertex is. This is when we're going to use that little formula I circled up above, that opposite of b over 2a. So looking up here at this equation, what is your b? What number's in the b spot? 4. Now it's going to be opposite of that down here. So it's going to become negative 4 And we said a was -1 a little bit ago, so I'm just going to drop that in. And how would that simplify? This would be +2. Okay, that's the x-coordinate of your vertex. So over here I'm going to write vertex. And I know that the x is 2, but I don't know what the y is. I need to find that yet, so I'm going to leave a little bit of space. But I do know, before we even talk about the y, I know that my axis of symmetry is going to go through that x value just like it did yesterday. When we found our vertex from just pulling it from the equation, we then knew where that dotted line went because it just went through the x value. So my axis of symmetry for number 3 is just going to be that line x equals 2. All right, now let's go back and let's find the y of our vertex. So like I said, there's 2 ways you can do this. You can either, especially like if you don't have a calculator and you're doing this at home that has like the table function, you take your 2 and you plug it back in to the original equation. So it would look like this. You would take -2 squared plus 4 times 2 plus 1. Okay, that would be one way to do it. When I was a student, that's how we did it because we didn't necessarily use the calculator to help us do the tables all the time. But because you all have access to these, it has the table function on it. It makes finding some of these things really easy for us. So I'm going to walk you through how to do that. So on your calculator, you're going to want to hit that table button, which would be right up at the top, right next to the clear button there. And then you're going to type in that equation, that -x squared plus 4x plus 1. And if you're not sure where some of these buttons are, put your hand up and we'll come help you. Make sure you're using the negative sign for the first one, not the minus sign, because your calculator won't do it right then. Everyone get it typed in okay? Okay, then you hit enter, you get to that next menu, and you know it says like start, it tells you any number that you want to start at. Well, I'm only focused right now on my vertex. What do we know the x is of the vertex? 2. So start at 2, because that's going to get you right to the vertex. So if you hit 2 for your start point, keep everything else the same. Go ahead and hit enter all the way down. You should get your table of values, right? What's 2 at? 5. So my vertex is at 2, 5. I would have gotten the same answer had I actually done the math up there. Because this would become a -4 plus 8. That's 3. What did I do wrong? Oh, that's 4 plus 1. -4 plus 8 is 4, plus 1 is 5. So it still gets you the same answer. That's just 2 different ways that you could go about finding it. I know last year, if you were in Algebra 2, you were taught how to use the tables. We use that pretty much exclusively in Algebra 2 to help just speed up that process a little bit. All right, so I'm going to go ahead and graph that point, 2, 5, because I know that's my vertex. And then I'm also going to go ahead and add in that axis of symmetry line just straight through that point. But now I need to find some other points, some like x-intercepts, y-intercepts. For the x-intercept, when I look at that one up there, I really don't think it's going to factor nicely because if you're thinking about what we would be doing with factoring, one, we'd have to figure out the negative. So like you'd have to make everything switch signs so that first term is positive, or you'd have to take the negative just times that 1. But it's not going to factor because you can't multiply anything to a -1 and have them also add to a -4. So factoring is not going to work for me. So I'm not going to do anything else other than go to my quadratic formula, which we learned last semester. Now I'm going to bring this down here because I'm going to need a little more space for this. But I'm going to write the quadratic formula in here. Does anyone remember the quadratic formula? Remember I sang you the song?
Something.
Something. Opposite of B.
Plus or minus the square root 4ac. B squared minus 4ac.
There you go.
2a. Yes.
Look at you guys. Good job. All over 2a. What'd you say?
I knew some of it.
You knew some of it. Good. That's what we're going to use here. Okay, so what number are we putting in for B?
4.
4. Good. Now the first one is going to become opposite, so I'm going to write -4 plus or minus underneath my square root here. Good. 4 squared minus 4. What's A? And C? And then all over 2 times -1. All right. Now it's a lot of numbers. Now we got to start simplifying. Use your calculator to help you here so that you don't make mistakes, especially with a lot of those signs going around. I'm going to zoom in on that. Okay, so let's try to simplify this a little bit. And I'm going to get decimals probably, just because if it didn't factor nicely, we're probably not dealing with whole numbers here. So we're probably going to get decimals or fractions of some sort, and that's okay. Because remember, we talked about that yesterday when we're graphing. We probably need to actually have physical points, so it's all right if we need to estimate where we think they are. All right, so let's try to do what we can here. So I've got -4. Let's just clean up that square root. 4 squared is 16. And then this becomes +4, so that should become 20 underneath the square root, and then all over a -2. What's the square root of 20? About. I need like a decimal. 4.5? Okay, so I need to find 2 answers here. So the first way would be you take -4, you add 4.5, divide it by -2. That's going to give us one of our x-intercepts. And so it's going to be some number, comma, 0. Can you guys tell me what the number is? So it's -4 plus 4.5 divided by -2. Anyone have something? I don't think that's right. -0.25. That's what I have written down. So there's one. And then for the other one, you're going to take -4 minus 4.5 divide by -2. What does that give me? Okay, comma, 0. All right, so I'm going to go ahead and graph these. Oh, it should be positive, right? Because it's -4 minus would be negative, but then divided by negative would be positive. So I'm just going to get rid of that. Good catch. Okay, so let's graph this. -0.25. Again, we're going to have to estimate where we think these are. So about there. And then 4.25 would be about there. Okay. Y-intercepts are way easier to find. Okay, because it's just your C value from up above. What did we say C was? 1. So your y-intercept is going to be that C, comma, 0. That's going to be your y-intercept. So then I'm going to go ahead and just add that up here. So I'm just going to go up 1. And then just like yesterday, if you would like to, you can reflect that point over the axis of symmetry. If I do that reflection, where's it going to go?
On 4, right?
Yeah, on 4, right? Because it's going to be 2 to the right of that red line. So you're going to go over 4, but still going up 1. Okay, and then we're going to graph our parabola here. Okay, and that's it. Now, a lot of that, like I said, you would have done last year. So hopefully some of it was like, I feel like I've seen this before. But some of it is a little new. Like, I don't think last year we really spent a ton of time finding x-intercepts. We more focused on vertex and y-intercept and just graphed using that. But like I said, with the x-intercepts, if you can't factor it, just go straight to quadratic, because that's probably going to be your best option as far as trying to find those answers. And it's okay if they're decimals. All right, so let's do another one together. Another one. Let's do the whole thing. Let's start with, let's just talk about what this is going to look like. Okay, so what's your A value? 2. So A is 2. So is this going to open up or open down? Good, it's going to open up. And because it's going to open up, it's going to look like this. The vertex is going to be at the way bottom. Like, I always think about these look like valleys. Like, you're at the very bottom of the valley and you got to climb your way out. So you're going to have a minimum value. Okay, let's start finding our vertex, because our vertex would be that minimum point. Now, vertex, I'm going to start with that formula, opposite of B over 2A. What are we putting in for B? -5. And then you guys told me earlier that A is 2, so it's going to be over that. Now, this isn't going to come out as nice as our last one did, because we're dealing with a fraction here. So fraction is fine. Since I'm graphing, though, I'm going to kind of lean more towards decimals because that's easier to graph. What does this come out to be? Okay. So my vertex is -1.25, and I need the y, so you can either plug it back in, or again, you can use your table. Might be easier to use your table on this one because of the decimal being what it is. So hit that table button, type in your equation, 2x squared plus 5x minus 7. This time start it at -1.25. I'm just going to tell you now before you get to your table values, your numbers are going to be gross, okay, because we're dealing with a decimal. And because of the way that the calculator is programmed, it's going to only show you decimals right now. So I'm just giving you a warning. What do you get for your y? Good. Yeah, that's kind of a gross number. So when we go to graph it, just do your best. So let's graph that point. Oh, it's going to even go off the graph. You got to hate it when that happens. Should be about right there. And then I'm going to go ahead and draw in my axis of symmetry. It should go just right through that point. Okay, let's skip the x-intercepts right now. Let's go to the y-intercept because that's easier to find. Remember, your y-intercept would be your c value, which is what number? -7. So we write that as -7, 0. I'm going to go ahead and graph that. The only issue with reflecting this one is you're going to have to just kind of estimate where you think it is, because that vertex point is not on like a solid number. It's in between coordinates. So you just have to kind of think about, if you were to reflect this point over, about where do you think it would go. Again, just do your best with that. Just think about performing a reflection. All right, now let's find our x-intercepts. I'm looking at that. If I were to have to factor that, you have to do the long factoring, like A times C stuff, which maybe it works, but I don't know. I don't know if it's worth the gamble to try to factor it. I think if anything, I might just be better off going straight to quadratic, because it's going to be the same amount of work if I do the long factoring with all the grouping stuff versus doing quadratic. You could try it if you wanted to, but I'm even just thinking 2 times 7 or -7 would be -14. And add to 5. Is that possible? So maybe it would be easier to factor. Should we try it?
Let's go for it. Let's get Sandy.
Okay, so if you don't remember how to factor these, you always have to take a times c. So that's where I got that negative 14 from, because I'm doing 2 times negative 7. And then we want it to add to 5. So negative or positive 7 and negative 2 would work, right? Okay, now you can't just go straight to your parentheses. Okay, you have to rewrite the problem and you have to rewrite the 5x with the 7 and the negative 2. So we say 2x squared, and it doesn't matter what order you go in here. So minus 2x plus 7x minus 7, and then we group. So you group the first two together and the last two together. What do we want to take out of the first set?
2x.
And what would that leave me with?
X minus 1.
Okay, how about out of the second set?
7.
Good, and we know it did it right because why?
They were the same.
Yeah, the parentheses match each other. Okay, so now if I was going to just write this out as factors, it would be 2x plus 7 and x minus 1. But I want to solve for x here, so I need to set them both equal to 0. The x minus 1 is easiest, because if you set that equal to 0, what do you get? 1. So there's one of them, 1, 0. What would the other one be?
Negative 7 over 2. I think.
Yes, and what would that be as a fraction? 3.5?
Negative.
Negative 3.5, comma 0. Those would be your x-intercepts. Okay, so now I'm going to graph those final 2 points. So I've got 1, 0, and negative 3.5, 0. And then I should be able to graph. Okay, so that one we were able to factor. But if you used quadratic, you'd still get the same answers I got there. So if you don't want to have to worry about testing factoring, you don't have to do it that way. You could have just used quadratic. You get the same 2 final answers, and then you put them on the graph and you make your parabola.
Nice.
Cool? All right. I appreciate the feedback, Tanner. I like it. Okay. Makes me feel like at least somebody's listening to what I'm saying up here. Okay, next one. Does the following function have a minimum or a maximum? Where does it occur, and what is the value? Remember, your minimum or maximum would be your vertex. Why would this one be a minimum and not a maximum?
Because it's positive.
Because it's positive. The A is positive, so this is going to open up, which means it's going to look like this. So this is going to have a minimum. So it's going to circle minimum up here. And then to find it, we just need to find the vertex, because that's always where the max or the min is going to happen, is at the vertex. So to find your vertex, we start with the opposite of b over 2a. What are you going to plug in?
16 over 2 times 4.
Yep. So that comes out to be 2. And then I would just use your table again. Type in that 4x squared minus 16x plus 1,000. Start it at 2 and tell me what you get for your vertex. It's going to be a big number. Not quite. So a minimum at that point, 2, 984. All right, we got one problem left to go, guys. We're almost done. So this last one is wanting us to still kind of think about using like the minimum, maximum, finding the vertex here. But we're also talking about looking at 2 different equations and trying to get them to kind of work together. So we're talking about a rectangular region that we're trying to enclose with fencing. We have 120 feet of fencing here. We want to find the dimensions of the rectangle that maximize the enclosed area. So I want to make sure I'm getting like the most space for this rectangular area, but also using all of my materials. I don't want to have any waste or any overlapping or anything like that. We want to find the maximum area. We've got two formulas that we have to work with here. What are they, and how do we get them into one variable? Well, we're talking about a rectangle. And we all know what a rectangle looks like. And we know that a rectangle has a length and a width. If we have 120 feet that we're trying to enclose this area with, that's perimeter because you're going around it. Now, I'm worried about the space on the inside of the fenced area. That's also my area of my rectangle. But I'm working with perimeter and I'm working with area here. Do you guys remember what your perimeter formula is for a rectangle?
I don't even know.
Well, you could add all the sides. There's a shorter way to write it, though, instead of saying L plus L plus W plus W. Yeah. And how do you find area of a rectangle? Length times width. Okay, so these are my two formulas that I'm working with. But I need them to kind of connect. Okay, I don't want them to be like so totally opposite of each other. So what I'm going to do is I'm going to rewrite that first equation because I know what the perimeter is because they're telling me how much fencing I have. That would go around the area. So that's going to be my perimeter. So instead of writing P here, I'm actually just going to cross off this P for right now and put a 120 in its place. And I'm going to rewrite this equation for, you could do either W or L. I'm going to choose to go with L. So I'm going to solve it for the letter L. The first thing I would do is I would move that 2W piece over by the 120. And I'm going to do that by subtracting. So it's going to say 120 minus 2W equals 2L. How would I get L by itself? Divide everything by 2. So what's 120 divided by 2? And then this would be W equals L. Okay, so now let's use this. We know L could be replaced with this quantity. So in my area formula, let's plug 60 minus W in for the L, only the L. If you were to distribute, what would it say? 60 W. Okay, now you could rewrite this. If you don't like it in that form because you want the W squared first, you can switch it. Okay, but we're trying to figure out, what this area would be. So now that I have this area formula written almost as a quadratic, I should be able to find my vertex, which would help me get to my dimensions. So remember, to find your vertex, you do opposite of B over 2A. So let's focus back on that now. So looking at this equation here, be really careful because I have it written backwards. What number is your B? The 60 is. So negative 60, and what's my A? Negative 1. If that's confusing because it's written backwards, then I would suggest that you flip it so that it's in the proper form, so you're not trying to figure out where those pieces are all at. What would this simplify to? 30. Good. That's going to be my W because that's going to be the X value of my vertex, which in this case would be my width. So my width is 30. I need to find my length. We said my length up here was represented like this, 60 minus the width. What would be 60 minus 30? 30. So 30 is also going to be my length. Okay, how would you find the area then? You times them. So what is that? 900. And what are we labeling this with? Feet. It's area squared. All right, questions on that last one? Ivy?
If both the length and the width are the same, then it could be a square, not a rectangle.
True, but all squares are rectangles, technically.
Oh, snake.
That's a geometry concept. All squares are considered rectangles because they hold all the same properties that a rectangle has. But not all rectangles are squares. It's like all thumbs are fingers, but not all fingers are thumbs. Do you remember when I talked to you about that when you were a sophomore?
No.
That's a good point to bring up. But all squares are technically considered rectangles. So I do think a better name for this would be a square, yes. But they said rectangle, which isn't wrong.